For this section, we're going to take a look at geometric series, and we're going to find the sum to a geometric series. Now, to be able to do this, you've got to know two formulas. The first formula is for the sum of a finite geometric series, and it's simply going to be S sub n, or the sum of the series, is equal to a sub 1, the first term, times 1 minus r, which is the common ratio, raised to the nth power, and n being the number of terms in that series, over 1 minus r. Now, pretty much everything here is going to be pretty easy to find except for the n value. So for the n value, what we've got to do is we've got to go back and we've got to use the geometric sequence explicit formula. And that's going to allow us to get n. So if you recall, that is a sub n is equal to a sub 1 times r, the common ratio, raised to the n minus 1 power. Once you have all that information, then finding the sum is actually not going to be too difficult. Let's now take a look at the process to find the sum of a geometric series. So here we've got the problem, which is to find the sum of 3 plus 6 plus 12 plus on and on and on until you hit the number 3072. So the first thing that we want to establish is, what is our first term? First term is 3, so I'm going to say a sub 1 is equal to 3. Then our last term, a sub n, is 3072. And then when we go up here, we can very easily figure out what the common ratio is. When we go from 3 to 6, since this is a geometric series, we're using multiplication. So what do you multiply 3 by to get to 6? And that's going to be 2. So we got to times 2. To get from 6 to 12, well, that's going to be times 2 as well. In the book, it shows you that the next thing is going to be 12 and then 24. So how do you get from 12 to 24? That again is times 2. So our common ratio is going to be 2. Now the n is what we still have to find before we can go ahead and use this formula here. So we're going to use the explicit formula for a geometric sequence to find out what the value of n is. When we do that, we're going to plug 3072 in on the left side of the equation is equal to 3 times, and then the common ratio 2 raised to the n minus 1 power. We need to isolate the n, so the first thing we're going to do is we're going to kick that 3 over to the other side. So divide both sides by 3. That's going to leave you with 1024 over here is equal to 2 to the n minus 1. Now what we can do is we can take that 1024 and we can actually take that down to a smaller, much smaller base. In fact, 1024 is the same thing as 2 to the 10th. So I'm going to bring this up here, and I'm going to rename 1024 2 to the 10th. And then that is equal to 2 to the n minus 1. Now if you recall from when we talked about exponents and logarithms, anytime that you've got two bases that are the same and they're set equal to each other, we can drop the bases and set the exponents equal to each other. So now we've got 10 is equal to n minus 1, which means that n is going to be equal to 11. So we can come over here and we can identify that n is equal to 11. Now that we've got that, we can take all of this information and plug it in here. And then you're just going to use a calculator to find the final answer on this one. So we've got the sum of this series is equal to a sub 1, 3, times 1 minus the common ratio of 2 raised to the 11th power over 1 minus r. So we end up with basically just a negative 1 down there. But what I would suggest is just take all of this right here, take this entire expression on the right side, plug that into your calculator, and what you're going to get is going to be the number 6141. So if we take every value in this series and add it up, we're going to get 6141.